As more countries and companies set their sights on space, it may make you wonder, what's the end goal? Do we simply want to be a spacefaring species? Exploring the solar system for the betterment of humanity? Or do people smell profit in space? While researching this video, I found out a lot of eye-opening reasons why mining in space, and especially on our moon, might well be something that we see happening in the next couple of decades. Why? Well, just wait until you find out what's actually there to be mined. The first substance is known as helium-3. You may have heard of helium-3 in sci-fi stories, as theories suggest it is the ideal substance for a clean type of nuclear reactor, with no radiation and no dangerous byproduct. It also has uses in medicine and radiation detectors. However, it is really rare on Earth. It does occur naturally and can be found in deposits of natural gas, for instance, but it's generally not viable to extract, as even in natural gas, there are only around 100 parts per billion. So let's say we had 1 billion cubic meters of natural gas, you'd only be able to extract around 15 kilograms of helium-3 from it. A lot of the time, that's not economically viable. We can also produce helium-3 as a byproduct of the radioactive decay of tritium. The problem with that though is that tritium is a crucial component of nuclear weapons, and so when the world slowed down the production of nuclear weapons, helium-3 stockpiles also started to diminish. Assuming we don't want more tritium in the world, it means we need to find another source of helium-3, especially if technology improves enough for helium-3 reactors to become a reality. Fortunately, we have a world in orbit around Earth right now, which has been bombarded by helium-3 for billions of years, thanks to the Sun. Earth's magnetic field deflects helium-3 traveling with the solar wind around the planet, whereas the Moon, with no magnetic field for protection, simply absorbs it in the top layer of the ground, called regolith. We aren't talking huge quantities, it has at most 50 parts per billion, but because it's all over the Moon, not just in tiny pockets, it can be collected alongside any other mining operation. It could also be used to power reactors on the Moon itself, which would help a moon base be self-sufficient. Some people think that helium-3 mining on the Moon will not be viable. However, China states that eventually mining helium-3 is one of the primary goals of their Chinese lunar exploration program. American, European and Indian scientists have all stated it is something they will consider further, and Russia is conducting a feasibility study on this right now. Even private companies are eyeing up the possibility. Because the parts per billion of helium-3 are relatively low, even in the Moon's regolith, it would make sense that whoever was mining for helium-3 would also be mining for something else in the regolith at the same time. But what else can be found in it? As it happens, the lunar regolith is packed with different materials. Look at this false color mosaic of the Moon, each color indicating different deposits of minerals found on the lunar surface. There are plenty of metals to be found on the Moon in large quantities, like iron, titanium, aluminium, silicon, calcium, and magnesium. Some of these metals are locked into hard-to-access minerals and oxides. However, separating the metals will often also produce useful byproducts like oxygen and hydrogen. They are super basic and not rare on Earth at all, but unlocking these elements on the Moon itself will allow for a colony to be self-sustaining, as oxygen means breathable air, hydrogen can be converted to fuel, and combining the two will produce water. Unprocessed regolith could also prove useful, as it could potentially be turned into lunacrete, useful for building infrastructure on the Moon without having to transport the materials from Earth. Glass could also easily be produced from lunar regolith. And as I mentioned in a previous video, while it's not super ideal, some plants can grow in lunar regolith, helping any lunar base to be self-sufficient in growing its own food, short of using hydroponics. But perhaps the most important resource found on the Moon are, ironically enough, metals known as rare earths. Interestingly, rare earths, which consist of this section of the periodic table, are not actually super rare on Earth. However, the difficulty in mining them is that they have not really collected into big deposits. Rather, they are dispersed through the Earth's crust. This means that they are exceptionally hard to mine on Earth, and there are only a few countries worldwide that have deposits large enough to do anything about it. Even then, most countries don't bother at all because of the massive environmental and human damages that come from the pollution of mining them. The only country that did not waver from these problems is China, as China has around 30% of the planet's rare earth supply, and because it is one of the only countries mining for them, they have a 95% control of the market. However, just as a side note, one of its big mines was actually found in Myanmar, and with the military coup that just took place, there might have been a shift in that mine's control. In any case, 95% control of the market puts China in a powerful position worldwide, especially seeing as these minerals are so valuable to our society, being components of various electronics and batteries. Because of the massive push recently to switch to electric vehicles with their huge battery packs, demand for these materials will only increase. So it's worthwhile considering where the minerals building these batteries come from. Are countries with somewhat sizable deposits like the US, Canada, Australia and South Africa going to start digging up their backyard to extract them? Or rather than pollute the earth further in our attempt to go green, is it actually more feasible to get these rare earths off the moon instead? Rare earths aren't any more common on the moon than on Earth, however some deposits have already been identified, and pollution on the moon would certainly not have any of the devastating environmental and human consequences attached to doing it here. As demand for these elements inevitably goes up in the coming decades, it could well be that mining for them on the moon becomes economically viable. And not only that, but a control on the market means control of the market price, and whichever country is in control will have a tremendous advantage. Will it be China maintaining their position? Or will some of the other spacefaring countries and companies want a piece of the pie? Only time will tell. Which leads on to another curious question. Who actually has mining rights on the moon? Well, it's a bit unclear. The main space treaty, which most countries in the world have signed up to, is called the Outer Space Treaty, and covers things like disallowing weapons of mass destruction in space, disallowing military bases in space, and disallowing claiming any celestial body. However, it doesn't really cover mining. Other treaties have been put forward which would cover mining in space, but so far only non-spacefaring countries have signed up for it. Right now, it could just be a matter of first come, first served. So there we have it, a look into the future of what may occur on the surface of the moon. What do you think? Can mining on the moon ever be worthwhile? Or is it an expensive, dangerous pipe dream? I'd love to hear your thoughts in the comments below. If you're like me, you've probably spent your life dreaming of a day when humans would travel to distant planets and build life-supporting outposts across the solar system. Well, we're not there yet, but the Artemis program may be the start of this bold endeavor. Fittingly named after Apollo's sister, the Greek goddess of the moon, the Artemis program is a spiritual sibling of the Apollo program, which landed the first astronauts on the moon. Not only does NASA plan to send human crew members back to the moon for the first time since 1972, but its additional objectives seem like straight up science fiction. They include the construction of a permanent lunar base and paving the way for the first crewed interplanetary mission, Mars. But to get there, NASA will first need to take its new technology for an uncrewed test drive and do further research into the effects of solar radiation on travelers. With so much riding on one mission, NASA will need everything to go perfectly, which is why they pushed back the launch date from 2017 to 2018, then 2019, and finally 2022. Now, after years of intense planning, the long-awaited moment has arrived. Is this the dawn of a new age of space exploration? The answer will depend on the success of Artemis 1. I'm Alex McColgan and you're watching Astrum. Join me today as we count down the history-making launch of Artemis 1, learn about NASA's ambitious goals for the Artemis program, and take a look under the hood of the Orion. the most advanced space shuttle ever built. On Monday, August 29th, 2022, Artemis 1 will launch from Complex 39B at the Kennedy Space Center. If all goes as planned, the day will see two firsts. It will be the first launch of NASA's Space Launch System rocket, a super heavy vehicle that will propel the Orion capsule into space, and the first flight of Orion itself, the only spacecraft currently capable of human deep space flight. While Artemis 1 will be an uncrewed mission, the Orion shuttle can support a crew of up to 6 humans. It is equipped with solar panels, a glass cockpit, an automated docking system, a life support system, and a launch abort system capable of ejecting the crew module in case a catastrophic failure occurs during ascent. The shuttle's primary propulsion comes from a single AJ-10 engine, while its secondary propulsion uses 8 R-4D11 engines as thrusters. In total, the Artemis 1 mission will last 25 days, traveling beyond the moon and back, while spending 6 of those days in a distant retrograde orbit, meaning it will orbit the moon opposite to the direction that the moon orbits Earth. In addition to testing NASA's latest equipment, Artemis 1 will have a secondary payload of 10 CubeSats, which contain small satellites that will conduct some nifty independent testing. These include an orbiter designed to search for lunar ice, and a solar-powered spacecraft capable of encountering near-Earth asteroids. Orion will be stacked on the Space Launch System, a towering rocket standing 111 meters tall. At blastoff, it will produce 8.8 million pounds of thrust, making it the most powerful rocket ever built. To create enough force to send this heavy rocket past Earth's gravitational pull, it will get power in several stages. At blastoff, the core stage and the 2 solid rocket boosters will fire up. Within minutes, the core stage, which houses 4 RS-25 engines, will burn through nearly 3 million liters of liquid propellant, while each booster will also burn through 900,000 kilograms of solid fuel. This does sound like a lot, but I don't think you can appreciate this in real terms without seeing it in action. So, purely for your visual enjoyment, here is a close-up of the engines being tested. Absolutely remarkable power. Once the core and boosters run out, the rocket will drop them, shedding excess weight. At this point, the Space Launch System will have reached Earth's low orbit, but the shuttle will still need additional power in order to escape Earth's gravity. To do this, the SLS will perform a big move, or translunar injection. The upper part of the rocket, called the Interim Cryogenic Propulsion Stage, will then fire up and drop away, accelerating the Orion shuttle to nearly 40,000 kilometers per hour, fast enough to send it on a trajectory to the moon. After the ICPS separates from Orion, it will drop its payload of 10 small satellites to do their own information gathering missions, while Orion will cruise to lunar space. There, Orion will fire up its maneuvering engines. These will send the shuttle around the dark side of the moon before its boosters can send it on a trajectory back to Earth. At this point, Orion will separate from its service module and re-enter Earth's atmosphere before splashing down with the help of parachutes. While other shuttles have used similar technologies in the past, SLS is unique in that it can carry extremely heavy payloads while sending human crews much further than they have ever traveled. This extra power will be critical for running complex and heavy payload missions, and hopefully end with NASA's horizon goal of a crewed mission to Mars. Unlike future Artemis missions, Artemis 1 will be uncrewed. Well, uncrewed by humans. But the shuttle will have several passengers. One will be Captain Munikin Campos, a mannequin equipped with radiation sensors and acceleration measurement instruments, as well as 2 phantoms shaped like female torsos. Keeping them company will be a plush Snoopy and Shaun the Sheep. While the latter 2 are presumably just to come along for the ride, Captain Campos and the Phantoms will have important jobs to do. Captain Campos will be test wearing the same Orion crew survival system suit that astronauts on future missions will wear during launch and re-entry, as well as the Matryoshka Astrorad Radiation Experiment, or MARE, which collects data on solar radiation. The female phantoms, meanwhile, contain synthetic organs that mimic hard and soft tissue, integrated with hundreds of radiation detectors. One phantom will wear an Astrorad radiation vest, and the other will fly unprotected as a control. NASA plans to send both men and women on future Artemis missions, so it's important to gather information on various health risks specific to both male and female biology. NASA have sent men to the moon before, but never a woman. This program will take future crews outside of the Earth's protective magnetic field, where they will be fully exposed to harsh solar and cosmic radiation. NASA hopes that the information they collect will be useful for protecting future crewed missions from that harm. If Artemis 1 is successful, NASA has big plans for the near future. Artemis 2, currently scheduled for launch in 2024, will carry 4 human crew members on a lunar flyby that will extend 16,000 kilometers beyond the moon, further than anyone has ever traveled before. In 2025, Artemis 3 will carry 4 crew members into lunar orbit, 2 of whom will land on the moon's south pole for the first time. This mission will also be the first time a female astronaut will walk on the moon. This will be a special occasion, and perhaps will be instrumental in helping future generations of women gain a love for space and STEM topics. And 2025 is not that far away, only 3 years to go. The astronauts that will be on this mission are already training for it as we speak. But after that, things will get even more exciting. In 2027, NASA plans to deliver the first module for the Lunar Gateway. The Gateway will be a permanent space station orbiting the moon, much as the International Space Station orbits Earth. It will house docking ports for visiting spacecraft and a habitable outpost called Halo for humans to live. A few years further down the line, NASA plans to build the Artemis base camp at the Shackleton crater on the lunar South Pole. With access to water ice and mineral resources, it's the ideal spot for a permanent outpost that would house up to 4 crew members for month-long stays. NASA also plans to develop an open-top lunar terrain vehicle, or LTV, which astronauts will be able to drive over 20 kilometers from base camp on the rough lunar surface. For longer ground trips, NASA plans to build a pressurized rover, which will allow astronauts to remain inside without their spacesuits. If all this sounds like a fun adventure to you, there's good news. Because as we continue to develop a human and robotic presence on the moon, it may eventually become a travel destination open to a wider public. That's right. Sometime in the future, you or I might be able to visit the moon. What would you bring? NASA is already asking people to share their ideas. You can share yours on Twitter, Facebook, or Instagram with the hashtag NASAMoonKit. This may make you wonder why there is suddenly this rush to get to the moon again. And while NASA would have never stopped going, the real reason is funding from the US government. And the US is becoming acutely aware of heavy competition in this sector. China's plans to also get to the moon. It's quickly becoming a race, and the US government does not want to be left behind. But as I mentioned earlier, the horizon goal of the Artemis program is not only to establish a sustainable human presence on the moon, but to provide a proving ground for an eventual crewed mission to Mars. In 2029, NASA will roll out Block 2, an even more powerful version of the Space Launch System, fully capable of sending the Orion space shuttle to Mars. If all goes as planned, NASA hopes to shift its attention to a Mars mission sometime in the 2030s. That's only a decade away. But to get there, a lot will have to go right, and it all starts with the Artemis 1 mission. Artemis 1 could be a watershed moment that jumpstarts a golden age of space exploration. I don't know about you, but when Artemis 1 blasts off, I will be glued to my computer watching all the latest news and updates. The time when we travel far beyond the Earth and inhabit other worlds might be closer than you think. So, if this is an idea that excites you, you'll definitely want to stick around, because I'll have a lot more about Artemis and space colonization in the future. You may have heard me mention the Artemis program on this channel, the ambition of NASA to get a human colony on the moon and eventually on Mars. A big part of this venture is Gateway, a joint effort by NASA, ESA, Roscosmos, JAXA, and the CSA, the same space agencies that are currently working together on the ISS. And like the ISS, Gateway will be a space station, but not around the orbit of Earth, but instead around the moon. So how will it work? What does it hope to achieve? And why have a space station around the moon in the first place? I'm Alex McColgan and you're watching Astrum, and in this video we will investigate the Gateway mission and find out why it is such a crucial part of NASA's ambitions. This video is a special collaboration with the Robotitus channel and our own Astrum Spanish channel. If you are Spanish speaking, then be sure to check out their channels in the description below. The Gateway mission will coincide with the launch of NASA's new rocket, the SLS, or the Space Launch System. This rocket is the most powerful built to date, even surpassing the old Saturn V rocket. It is huge, and it has to be because NASA hopes to be able to launch 130 tons worth of payload into a low Earth orbit, with a smaller, yet still very heavy payload to even further destinations. This will be important because, as I mentioned, the end goal of the Artemis program is to get humans to the moon and Mars, and humans tend to need a little bit more to keep them alive than a robotic mission would. Launching all this life support into space means that not only has Gateway been designed to be a communications repeater for several deep space missions, but it will also serve as a pit stop. It incorporates a cabin module in which crews can prepare before embarking on other missions. However, unlike SpaceX rockets, which are trying to cut costs by utilizing reusable boosters, an SLS launch will be expensive as it uses disposable boosters. Combine this with the cost of research and development, and this could bring the cost per launch in the region of an eye-watering $2 billion. As such, the SLS has had its opponents throughout development, but regardless, they are committed now, and it's only a year away from its first voyage. Putting the arguments of cost aside, the SLS will be the most powerful rocket ever created by NASA. A true monster capable of sending a large amount of cargo into space with more power than ever. Just look at some of these tests they have recently run. One launch alone could get around 45 tons to Mars. The rocket's first task will be to get the Orion module, a human-ready capsule that will provide the housing needed to get a crew into space and back again, re-entering into Earth's atmosphere safely with a heat shield and parachute. The loading capacity of the SLS will not only allow the launch of Orion and its crew, but also some of the different modular components and instruments needed to assemble Gateway. As such, the construction of Gateway will be a long process, as they won't be able to launch the whole of it in one go. In fact, construction is not expected to finish until 2026, and that's only for the most basic and necessary modules. Fortunately, due to Gateway's modular design, possibilities to gradually expand the space station is a real and a likely possibility, depending on the needs of future missions. Although NASA have plans to get to Mars in the 2030s, NASA is also highly dependent on the budget it receives. So, while there are several missions proposed up until 2028, including several piloted missions, they depend on the success of the first missions and whether NASA continues to get the budget it's getting from the US government. At this point though, I can't envisage it not going ahead, barring total disaster, as China are hot on America's heels and have equally ambitious sights set on the moon and beyond. And America's efforts are probably spurred on by China's advances in space. We might have a good old-fashioned space race on our hands. Now, While this is done in the name of science, with the billions of tons of precious metals in space, and with the progress in technology space missions bring, you could certainly see this being commercially viable, as well as being important in a militaristic sense. And you can be sure neither party wants to be left behind on this one. Going back to Gateway, NASA intends to start with the basics, so the first phase of Gateway's construction will focus on installing the power and propulsion modules, to expand it later with the Halo module, which will be a very basic space habitat which will allow the stay of at least 30 days for a crew of 4 people. During the construction process of Gateway, NASA will send a rover to the lunar South Pole. The rover's special task is to map the location of water trapped at the bottom of the craters, so we can better understand just how much is there and to see how pure it is. This is because one of the proposed places for a settlement on the moon is around its South Pole, where the presence of water ice has been confirmed, hidden at the bottom of eternally dark craters, which protect the ice from the sun's rays. These craters could be perfect candidates for a possible habitat, as they would protect astronauts residing there too. The peaks around the craters, on the other hand, would be exposed to the most amount of sunlight, allowing solar arrays to capture energy from the sun more easily, for power and for the cultivation of plants. Remember, solar arrays wouldn't be so effective anywhere else on the moon due to its days that last a month, and 2 weeks in the dark isn't so useful there. Although we know from previous missions that water does exist at the bottom of the South Pole craters, we don't have a good handle on how much, as the lack of light there makes observations from space impossible. This is going to be one of the obstacles the rover will need to overcome. It will have to travel into a crater on battery power alone, and leave again before it runs out, so that the rover can charge them up again using the solar panels. The design of the rover is still pending, and in fact it will be picked as part of a design contest proposed by NASA to different companies. Once Gateway is built, NASA plans to launch the Artemis 3 mission, whose crew will be stationed at Gateway, using the Orion module to expand the space station's living space. Scientists will be able to study the effect on astronauts outside the substantial protection of the Earth's magnetosphere. During these short stays, they will test whether radiation exposure can be reduced to an acceptable amount. Also, as part of the mission, 2 members of the crew will remain in orbiting Gateway, while the other 2 will land at the South Pole of the moon, where they will remain for about 1 week. They too will be expected to perform several moonwalks, again to examine samples of water ice and perform other scientific observations around the pole. It is proposed that included in this team will be the first female astronaut on the moon, although names have not yet been picked. The spacesuits they use will be a vast improvement over the Apollo counterparts. They incorporate a new design to grant much more mobility. If you remember the videos of the first Apollo missions to the moon, you will remember that the astronauts moved around very awkwardly, jumping around like rabbits. In this mission they can walk and flex their legs, so thanks to this greater mobility and the use of modern cameras, we can expect a series of epic videos of these astronauts walking on the moon. Building on the Artemis 3 mission, NASA is planning to start construction on the moon itself to build a lunar colony that they hope will one day be self-sufficient. Everything that is learned in this colony in the relative proximity to Earth will be valuable experience which can be used eventually on the Red Planet. This includes oxygen production systems, water recycling, plant cultivation, and in general, making the rooms suitable for a long-term human presence. Going to the moon may be more economically viable than going to Mars, at least in the short term, because not only are the costs of sending something to the moon lower, but the moon can be a source of rare materials, for instance helium-3, which would be useful in a future nuclear fusion generator on the moon, and it might have more uses on Earth too. This element is exceptionally rare on Earth, and at one point it reached the price of $2,000 per gram. In addition, the moon could be used as a steel plant for the manufacture of metal foams. On Earth, this is achieved by injecting pressurized air into cast metal, but the process is tricky because bubbles can be produced that rise and explode, making the manufacturing of metal foams on Earth very difficult and expensive. On the other hand, in the low lunar gravity, this process would be much simpler, and the spongy structure of the metal much more uniform and of a higher quality. Once the material is ready, it is very easy to send it to Earth, since you don't need a large rocket due to the weak lunar gravity. One possibility is that it could be launched back to Earth with a magnetic catapult, something like a railgun, launching the order back to Earth or into orbit around the Moon to be picked up by a spacecraft later on. Again though, that's something for the far future. After Artemis 3, there are up to 4 more proposed missions, which will continue to expand Gateway as a hub for more lunar missions, but with the end goal looking to finally send humans to Mars. So, fingers crossed for the success of these missions. I feel like exploration is in humanity's blood, and these really are the new frontiers in this day and age. And with China pressing ahead with their own space program, we could be in for some exciting years ahead with regards to space exploration. You may have heard in the news last year that Richard Branson and Jeff Bezos have become the first billionaires to get into space themselves. Whatever your thoughts on this, it marks a fascinating point in human history. In the past, the space race was exclusively a contest or collaboration of nations, but now private companies are beginning to enter the fray. Why this sudden change? And what does this mean for the future of space travel and exploration now that businesses are starting to look to the stars? What might it mean for humanity's future? I'm Alex McColgan and you're watching Astrum. And while it might be a little too early to say for sure what the future brings, we can perhaps gain greater insights into these questions by looking at why some of these companies and individuals are reaching for the stars. The commercialization of space is not a new thing. In 1962, just 5 years after the first artificial satellite was launched by the USSR, the first commercial satellite, Telstar 1, was launched by the AT&T Corporation as a means of broadcasting American television programs to Europe. It was launched using a NASA rocket. In 1975, Ortrag, or the first company to attempt to develop an alternative propulsion system for rockets, was founded in Stuttgart, Germany. And in 1984, the US President Ronald Reagan signed the Commercial Space Launch Act, intending to encourage companies to explore space. Satellites have been a staple of modern life for many years now, enabling internet connections and helping us to navigate through tools like sat-navs, among other things. In other words, companies have already been commercializing space for some time. So what's different about these recent space flights? Well, these flights are the first time that private companies have built their own rockets and flown their own founders into space. They represent a turning point in space exploration and the beginning of a fledgling space tourism industry where wealthy individuals can pay to spend time in space. This could have larger future impacts than you might think, as we'll explore later in the video. But let's first take a look at some of the companies that have been developing their own rockets to travel into space. In particular, we'll be looking at Virgin Galactic, Blue Origin, and SpaceX, as the differing approaches of all of these companies offer us the best glimpses of the many possible outcomes of commercial space flights. To begin with, let's examine Virgin Galactic, as it was Richard Branson who won the race to be the first billionaire to fly into space on their own rocket. He did this on the 11th of July in 2021, but had actually created Virgin Galactic much earlier, back in 2004. Branson's company, the Virgin Group, had taken an interest in the idea of space tourism and had noted that another smaller company, Scaled Composites, was developing their own rocket called Spaceship One. Scaled Composites hoped to win the Ansari X Prize for the first private crewed spacecraft. Branson reached out to Scaled Composites and convinced them to make the Virgin Group their sole customer of future spacecrafts if they succeeded. They did so on October 4th, 2004, with Spaceship One flying to 112 kilometers in altitude and returning to the Earth safely, and with a crew. It's worth noting that space is officially recognized as starting at 100 kilometers by many agencies at a point known as the Kármán line, named after Theodor von Kármán, the first person who tried to define such a boundary. Spaceship One did successfully fly over the Kármán line boundary. However, NASA sees space as beginning at around 80 kilometers. With that success under their belt, Scaled Composites and Virgin Galactic began working together to create a whole fleet of new spaceships, model name Spaceship Two, with Scaled Composites providing the technical know-how and Virgin Galactic providing much of the initial capital. Together, they founded the Spaceship Company, with Virgin owning 70% of the shares, but eventually this rose to 100% when Virgin bought out the company completely. The rocket they designed had one aim in mind: space tourism. To get 6 passengers and 2 pilots up into space, to allow them to see incredible views of the Earth, and to experience a feeling of weightlessness. To do this, they used an interesting method. Instead of just creating a rocket, they actually attached their Spaceship Two to a specialized aircraft called White Knight 2, which carried the Spaceship Two up to an altitude of 15,000 meters. Then, the spacecraft is released and activates its rocket booster, which takes it to supersonic speeds in just 8 seconds. The Spaceship Two then begins climbing, arcing higher and higher until it was pointed straight up. It reaches over 80 kilometers, the NASA definition of the boundary of space. All in all, this trip up takes roughly an hour. At the height of Spaceship Two's climb, it cuts its thrusters and lets gravity begin to slow its acceleration. This drop in acceleration results in the passengers on board feeling weightless. Sort of like when you throw a ball straight up in the air, there is a brief moment when the ball is neither rising nor falling. This moment of perfect balance between upward motion and gravitational pull lasts for roughly 5 minutes, after which the Spaceship Two begins to fall to the Earth. It glides its way back down much slower than a capsule re-entering the atmosphere by using a feathered re-entry system before gliding its way back to its launch pad. This part of the trip would also take about an hour, making for a 2-hour round trip total. With the success of Richard Branson getting into space, Virgin Galactic will be looking to start flying passengers into space within this year. But why does this matter? Ticket prices for a flight on Spaceship Two, or possibly Spaceship 3 by then, will cost $250,000, far outside the price range of most people. Shouldn't that money instead be invested in issues closer to home, rather than providing the rich with a fun day out? Well, as our next billionaire has pointed out, space tourism might just be the way that space travel becomes accessible to everyone. Jeff Bezos, the founder of Amazon, created his own space company, Blue Origin, with this aim in mind. Bezos has always had an interest in space, mentioning in an interview at the age of 18 his desire to build space hotels, amusement parks and colonies for 2 to 3 million people who would be in orbit. However, this was not simply as a way to make money. Bezos explained at the time that this was a way of preserving Earth. By moving certain amounts of the population off the planet, it might reduce the strain on the environment. In 2000, when Bezos was wealthy enough from the success of Amazon to start making his dreams become a reality, he began Blue Origin, funding it privately with his own money. However, to begin with, Bezos kept the project fairly secret. He did not reveal publicly that he had founded the company, and even in 2003, when he started buying land for a possible launch site, the public was left wondering what he wanted the land for. Unlike Virgin Galactic, which leaned on investors to fund its research, and so was very open with its aims, Blue Origin did not make much public noise for about a decade. It accepted a contract from NASA in 2009, and did publish a rough report on the progress of the rocket it was developing, but it was not until 2015 that it began to speak more openly about its goals. And those goals had not changed much from when Bezos was young. Blue Origin's first commercial rocket, the New Shepard, named after Alan Shepard, the first American to go into space, was also a tourism rocket. But Bezos made it clear in speeches that he did not intend to stop there. In his mind, this was just a beginning. In 2016, he made a speech where he compared the space industry now with aviation back in its infant days. In the early days of airplane flight, a big portion of people flying were those seeking the simple thrill of flying in a plane. This tourism and entertainment factor expanded interest in the industry, which made it so many companies developed the technology further. Nowadays, almost anyone can buy a plane ticket. Although spacecraft tickets are extremely expensive for now, in the long run, Bezos said that the space industry could go the same way. Bezos's rocket, the New Shepard, is a little different in design from Branson's. It has a more standard thruster that carries an observation pod up into the sky, which then detaches. It also goes higher than Spaceship Two, crossing the Kármán line to a height of around 107 kilometers. It also travels much faster. The whole trip, from takeoff to landing, will only last about 11 minutes, unlike Virgin Galactic's 2 hours, although it will no doubt carry a similar price tag for tickets. And Bezos is already looking ahead. Although 107 kilometers is over the Kármán line, it is still far from true orbit. Blue Origin's future goal is to get their next rocket, named New Glenn after another astronaut, into orbit. And as for the project after that, well, the name is New Armstrong. It is clear that Blue Origin intends to make its way to the moon. This is in line with Bezos' stated objectives, to pave the way for industry to more accessibly get into space. Although he doesn't expect to see it in his lifetime, Bezos has said that he expects much of the Earth's heavy industry to one day be done in space. Our last billionaire, however, has his eyes on an even further goal. Elon Musk's company, SpaceX, is a little different from the other two. While Virgin Galactic and Blue Origin focus on space tourism, SpaceX has been more focused on commercial ventures. Since its founding in 2002, SpaceX has grown to dominate the market, taking half of the contracts to launch satellites into space. Part of its success in this area is due to the fact that its rocket, the Falcon 9, is reusable. This reusability drastically reduces the cost of launches, making launching satellites and other cargo much cheaper. The Falcon 9 is much larger than New Shepard or Spaceship Two. While the latter two are roughly comparable, at 18 meters in length each, Falcon 9 is 70 meters. Its thrusters are powerful enough to get it into orbit. It carries a reusable cargo capsule named the Dragon, the first of which carried supplies up to the International Space Station. The Falcon 9 is able to carry 5,500 kilograms of weight into orbit, or more if they're willing to sacrifice the reusability of the rocket. This ability to transport cargo reflects a possible future purpose of SpaceX, to carry freight to Mars. Elon Musk has always made it clear that he intends to one day see a colony on Mars, and in 2001, his company conceptualized greenhouses that might grow plants there. Any such colony will no doubt need supplies from Earth, particularly in its early days, as vital equipment and personnel would need to be transported over. Any company with the large-scale capability to transport heavy weights between Earth and Mars would stand to make a lot of money. In 2001, Musk attempted to buy rockets that might start the process of getting supplies to Mars, but realized that it would be cheaper to create his own. Thanks to the success of SpaceX, which is now currently valued at well over $75 billion, Musk has gained the funds necessary to further his dream. SpaceX is developing a new line of rocket known as Starship, which they hope will be able to go to the moon and later be able to transport 100 tons to Mars before refueling there and flying back. It will be an incredible achievement, and although it takes roughly 6 months to travel to Mars, it will make the Red Planet far more accessible to humankind. Space tourism, lunar landings, orbiting facilities and refueling stations, shipping to Mars. These are all the stated objectives of the commercial interests looking at space. And although they're still a long way from achieving some of those goals, The fact that they are making the progress they are makes those future goals seem all the more plausible. This is why billionaires traveling into the edges of space in their own rockets is exciting. It not only marks the beginning of an age where trips for the average person traveling to another planet could one day be real, but it could lead the way for humanity truly being an interplanetary species. Now, I know these companies have their controversies, which I avoided in this video. However, what company seems the most promising to you? Maybe there's a company I didn't mention that has real potential too. Do you think it's good for there to be healthy competition in this industry? Let me know what you think in the comments below.
10, 9.
It would be pretty impressive if you somehow missed the news over this last weekend about the successful SpaceX NASA launch to the International Space Station.
Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
Some of you may be wondering though, what is so significant about this? We've been sending humans to space for a long time, and this trip isn't even to anywhere far away. The ISS is only a few hundred kilometers above the surface of Earth after all. Well, there's a couple of things that make this exciting for space exploration and space travel in general. The obvious one, the one everyone has been talking about with every given opportunity, is that this marks the first time astronauts have lifted off from American soil since 2011, since the discontinuation of the Space Shuttle program. This is significant because it means the US is really back in the game now. During this gap between the end of the Space Shuttle program and today, only the Russians had capabilities to send astronauts to space. Every launch went via them and their Soyuz rocket, costing the US an estimated $86 million per seat. Russia have put their price up over this last decade, perhaps cashing in on the fact that they had a monopoly on the market. The lowest NASA paid Russia was $21.8 million per seat back in 2007, and the design of the Soyuz hasn't really changed since then. Which brings us on to the second most significant part of this mission. NASA has commissioned private contractors to build the next generation of manned launch vehicles and capsules. The idea is that having some competition in this market will be a good thing for bringing prices down. So, while the Russians have been charging $86 million per seat, SpaceX, on the other hand, will be charging about $55 million per seat initially. As more orders come in, they expect to be able to reduce this price tag down further to the $10 to $20 million mark. SpaceX can go so low because they utilize reusable boosters, which should reduce their overall cost considerably. Another of the contractors, Boeing, are also testing their own capsule, although their price per seat will be considerably higher initially at $90 million. SpaceX has had a big head start. They have been flying robotic cargo missions to the ISS since 2012, which has meant Boeing has been playing catch-up to match a similar launch schedule to SpaceX. With time though, those costs should also be reduced. This competition in the industry is good, because cheaper manned missions to space should mean a greater capacity for more missions in the future, which is great news for space enthusiasts. To give you some comparison about the costs involved with space travel, NASA is still working on their own launch vehicle called the SLS. This will be more than just a taxi service for astronauts. It's designed to shift a serious amount of cargo far out into our solar system too. However, if you include all the R&D costs into each of its expected flights, we are looking at over $2 billion per launch. Compared to SpaceX's Falcon Heavy, which Elon Musk claims would only cost NASA $150 million per launch. Now, the SLS would get a little less than twice the amount of cargo to low Earth orbit, 130 tons compared to Falcon Heavy's 70 tons. However, we are seeing signs already that maybe the private sector can do it better. We are still in early days yet. In the coming years, seeing the reliability of all the craft will be one of the most important factors to decide whether one way or another is the most successful path or not. but the fact that there are now options will be crucially important for the future of spaceflight. So well done SpaceX and NASA, and good luck Boeing and the teams behind the SLS and all other space agencies around the world. Let's make this upcoming decade one to remember for space travel. When you think of the space race, you probably imagine the tense Cold War era battle between the US and the Soviet Union. But what if I told you there was another player in the game? While the superpowers wrestled for space dominance, a small and newly independent nation started developing its own ambitions of reaching the stars and beating the big dogs to it. The story of Zambia's space program is a great example of humanity's overpowering curiosity to explore and understand the cosmos, no matter where we're from, and how far we're willing to go to do so. It's also a reminder that history is shaped by those who get to tell it, and it isn't only the loudest voices that leave the biggest legacies. I'm Alex McColgan, and you're watching Astrum. Join me today as we dive into the little-known story of the Zambian space program, their proposed mission, unconventional training practices, and the lasting impact of their leader's vision. After World War II, the US and the Soviet Union realized that in a world with nuclear weapons, there can only be one superpower. They entered a bitter struggle for dominance, each racing to stay one step ahead of the other, engineering increasingly powerful rocketry and weapons technology. It didn't take long for their arms race to become a space race. By the early 1960s, new milestones in space exploration were being made every year. Both programs had unwavering political and public support, which meant lots of funding, press, and progress. All eyes were on them, and the stakes were super high. Half a world away, Edward Mukuka Unkoloso was watching too. A passionate science school teacher, he dreamed of one day creating his own Zambian space program to rival those of the Americans and Soviets. The only problem? His country was facing its own political struggle, the struggle for independence. Zambia, then called Northern Rhodesia, had been under British colonial rule since 1888. Through the 1950s, Zambians grew increasingly disillusioned with colonialist policies such as racial discrimination and limited political representation for Africans. Nkoloso was one of these Africans. After fighting in World War II on behalf of Britain, he opened a school for Zambians, which was promptly shut down by the British authorities. This pushed him to join the Zambian resistance movement and later the United National Independence Party. Nkoloso also worked hard for both causes close to his heart. While one hand was fighting for Zambian independence, the other was building the Zambia National Academy of Science, Space Research and Philosophy, which opened in 1960. The details of what went down at his academy are murky, but it seems this is where Nkoloso's idea for a Zambian space mission emerged. He was going to send Zambian astronauts, or Afronauts as he called them, to the moon and then to Mars. And he was going to do it before the US or the Soviet Union. We have been studying the planet through telescopes at our headquarters and are now certain Mars is populated by primitive natives, he says. Specially trained space girl Marta Mwambwa, 2 cats, also specially trained, and a missionary will be launched in our first rocket. But I have warned the missionary he must not force Christianity on the people of Mars if they do not want it. If you're wondering about the cats, they were thrown in partly for companionship for Marta, partly as a survival testing device. Marta was to throw one out onto the Martian surface on arrival, and if it survived, she'd know it was safe for her to emerge too. In 1964, Nkoloso announced his mission was ready. The first rocket was planned to launch on Zambia's Independence Day, October 24th, 1964. Now, going up into space is never an easy task. You've got to be in tip-top physical and mental shape to be an astronaut. In the early days of the space age, some training exercises were grueling or even downright dangerous. In the 1960s, cosmonauts were undergoing all kinds of rigorous physical training and conditioning. For instance, they were put in a centrifuge to recreate the intense G-forces of launch, which is incredibly dangerous as it puts a lot of strain on your heart and lungs. Such training could lead to oxygen starvation and cause trainees to pass out. It also limits the ability of your heart to pump blood upwards against gravity to your brain and other vital organs. Long-term exposure to multiple G-forces can lead to complications like arrhythmias over time. Cosmonauts also underwent parabolic flights for weightlessness training, named for the parabolic flight path the aircraft follows. At the top of the curve, the acceleration of the aircraft cancels out the acceleration due to gravity, achieving a feeling of momentary weightlessness for the passengers. It's kind of like when you're on a swing, and at the highest point of your swing, you feel weightless for just a moment. Except in an aircraft with the right trajectory, you can feel that microgravity for up to 40 seconds. While effective, these flights were risky due to the high potential for mechanical failure or pilot error, as only the most skilled pilots at the time could pull off the precise maneuvers needed. Cosmonauts also had to be prepared to confront an incredibly harsh environment in the event their mission might land far from recovery zones. Wilderness survival training in Siberia was an essential part of mission training, which sounds absolutely brutal. Even in modern times, the lengths some will go through to reach out for space can be quite perilous. Daredevil Mike Hughes discovered that after constructing his own homemade rocket in an attempt to prove his belief that the Earth is flat. In February 2020, his rocket tragically malfunctioned during a test flight, killing him instantly. While no one died in the Zambia space program, its training definitely raised some eyebrows. Nkosi designed a series of mental and physical tests to prepare his astronauts for space travel. One such exercise was teaching his recruits to walk on their hands, claiming that this was the only way people can walk on the moon. It's unclear where that idea came from, since he was an educated man and was presumably following the latest space race updates closely. To simulate zero gravity, he'd put his recruits in an oil barrel one by one and roll them down a hill, bouncing them over rough ground to simulate turbulence. When they hit a particularly big bump, he celebrated, claiming they'd just experienced anti-gravity conditions, an exercise which is obviously uncomfortable, potentially dangerous, and definitely not scientifically sound. Another approach they took to weightlessness training actually involved something I mentioned earlier. They tied 2 ropes into a swing and would swing on it, getting higher and higher. At the time they least expected it, another trainee would cut the rope so they could experience the free fall to the ground. Not a much better approach. And the rocket ship they were training for? It was a 10-foot oil barrel with an air hole in it, made of space-grade aluminium and copper. Care to know how they were initially planning to launch it? With a catapult. His willing recruits were a group of 12 teenagers he was training at the space program's HQ, a secret location 7 miles outside of Lusaka, at an abandoned farmhouse. Marta Mwambwa, the girl who was supposed to actually fly the mission, was just 16 years old at the time. NASA had ex-military Air Force pilots and engineers in state-of-the-art, purpose-built facilities. Nkosi had a dozen high school children in a field. Now, I know it seems like I'm making this up, but this really happened, as absurd as it all sounds. And that's what's so mysterious about Nkosi. He was an intelligent guy. He read about space. He was a science teacher, a veteran, and a valued member of the political movement that led to the nation's independence. So, what was his end game? Why was he talking about this mission if he must have known it wasn't viable? Some have speculated that his motivation to join the space race came from a place of national pride and a desire to elevate not just Zambia, but all of Africa to the world stage. He was seen as working to dismantle stereotypes about Africans that had held steady during the colonial era, and instead show that Africans are capable of contributing to scientific and technological advancements. If his goal was to get the international press talking, he certainly succeeded. Time magazine ran an article about him, as did several other outlets. News crews went out to film video interviews with him and record his team training. His colourful personality and outlandish claims definitely helped capture public imagination and media curiosity, even if it wasn't clear if he was serious or not. Uncle Osso maintained he was serious until his death in 1989. When asked about it in 2016, the first president of Zambia, Kenneth Kaunda, said, "It wasn't a real thing, it was more for fun than anything else." There's another theory that his whole project was satire, a parody of the Western conquest of other nations. There didn't seem to be a reason for such goofy-looking training exercises other than to capture people's attention. Even during his interviews, he always stayed in character with his standard issue helmet and flowing cape, but he'd throw in subtle jibes at the world powers, calling them imperialist neo-colonialists who were scared of Zambia's space knowledge. Remember the Christian missionary he wanted to send to Mars with the girl and the cats? He had explicitly warned the missionary he must not force Christianity on the people of Mars if they do not want it, a luxury many colonizing nations did not afford their conquered lands. Perhaps unsurprisingly, Uncle Osso's project never received public or political support. He had written to UNESCO asking for a £7 million grant to make his mission a reality, a drop in the bucket compared to NASA's $25.4 billion Apollo funding. It's also been reported he asked for $1.9 billion from private foreign sources, but the Ministry of Power, Transport and Communication was quick to clarify this request was not made on behalf of the government. In the end, the only funding he got was 10 rupees from a young Indian boy. Most Zambians did not resonate with the space program and didn't feel it accurately represented the feelings of the nation. In fact, his own Afronauts deserted him. 2 recruits reportedly went out drinking one night and were never seen again. Another left to join a travelling song and dance group. Amata ended up having a child of her own and staying home instead of going to Mars. In hindsight, we can only speculate what Uncle Osso's true intentions might have been. Maybe it was a ruse to make international headlines and get the name of a newly independent country out there. Given Uncle Osso's history as a revolutionary, it wouldn't be out of character for him to want to replace the name Northern Rhodesia with Zambia on the world stage. And while he had everyone's attention, he might have thrown in some satire aimed at the superpowers just for fun. Or he might have hoped, against all odds, that their hard work and determination would impress the right people and actually get Zambians into space. Or perhaps he was simply trying to make some kids feel like they were part of something big and important. What we do know is that he never let setbacks squander his determination and belief in his vision. Thanks to him, even for a brief moment, Zambia entered the space race against the US and Soviets. This is a vibrant story of one man's audacity, determination, and self-belief. The reality is that not everyone who dreams of making it into space ends up going there. But whether he meant to or not, Uncle Osso told the world, "We are here, we are Zambian, and we are free." In a way, he reminded us that those epic, larger-than-life endeavors like reaching for the stars and exploring the vastness of the universe stem from a desire innate in us all. And that in itself makes it a story worth telling. There are exactly 2 space stations in orbit around planet Earth right now. One of them you will have heard of, the International Space Station. But what about the other one? Tiangong, or the Heavenly Palace, is the 3rd in a series of space stations launched and maintained by the People's Republic of China. It has been in orbit since 2021, yet Western media reports much less on what happens aboard this second, enigmatic bastion hanging in space's expanse. So, what is going on up there? I decided to look into it, and when I found the list of their past and current experiments, and as I pieced together what it meant, the sheer scale of China's ambitions stun me. We are familiar with the sorts of things being done on the ISS, experiments aimed at better understanding how humans might adapt to space environments and uncovering the mysteries of our universe and its physics, inevitably general in scope, reflected in the differing priorities and the emphases of each nation collaborating within it. But inside Tiangong, the goal is more focused. What is that goal? The answer might surprise you. I'm Alex McColgan, and you're watching Astrum. Join with me today as we uncover the goings-on within Tiangong Space Station and discover what implications this might have on the future of humanity in space. Unlike the ISS, which has been in orbit for over 25 years, China's own space station endeavors only started in 2011 with the launch of the first Tiangong space station. That's right, they launched the whole space station in one go. This was not a complex construction. Tiangong 1 was a simple tube-like prototype consisting of a sleeping and living station for Chinese astronauts, otherwise known as taikonauts, a habitable lab for docking and orbital experiments, and a module for propulsion. The whole station was only 10.4 meters long compared to the ISS 108 meters, and had 2 solar panels on either side. Its simplicity was a reflection of China's purposes for it, to master rendezvous and docking techniques, and to only dip their toes in the water of space habitation. Tiangong 1 was only in space for a little under 7 years. China did succeed in sending both crewed and uncrewed missions to Tiangong 1, and buoyed by this success, they upped their game with plans for a larger space station. To achieve this goal, more tests would be needed. In 2016, a second space station was launched, which also bore the name of Tiangong. Tiangong 2 was intended to field test key technologies that would be needed for the larger space station, and was deorbited just a few years later in 2019 once its tasks were completed. The road was paved for China's Tiangong 3. Tiangong 3, often referred to as just Tiangong, aims to be the home of thousands of experiments. To further this goal, Tiangong consists of the Tianhe core module for crew to live in and 2 science modules, Wentian and the Mengtian. The former designed to see space's impact on living things and to develop medical technologies, while the second focused on microgravity and its effects on fluid behavior, combustion, and more. Rotating solar panels connect to the station and turn to face the sun, allowing Tiangong to maximize its energy collection. The Tiangong has an external robotic arm that can carry a taikonaut to various parts of the station, allowing extravehicular activities to be carried out. The whole space station weighs 100 tons and is 55 meters long, and can house up to 6 taikonauts at once. Smaller than the ISS, but still large enough that it had to be assembled module by module in space, with modules launched between 2021 and 2022. Life on board the Tiangong is in many ways similar to life aboard the ISS. China tries to keep its taikonauts happy with a wide range of space foods, 120 different kinds. Naturally, given the muscle atrophying effect of microgravity, it's important for taikonauts to spend time each day exercising, or else they'd have a very bad time of things when they came back to Earth. Similar to the ISS, one of the main aims of the Tiangong space station is the popularization of science. So taikonauts spend some of their time taking part in presentations and collaborations with schools in China. For instance, this demonstration involving what fire looks like when there's no gravity. Students are also involved in growing rice seeds from the same batch of seeds growing on Tiangong, which will help Chinese scientists explore the impacts of microgravity on plant growth. Tiangong is home to several live plants, although some care has to be taken while watering them. Nothing so far here is too much out of the ordinary. However, there is a theme to the experiments being carried out on Tiangong over the course of its 15-year lifespan. 5 themes, in fact, that all point to a truly ambitious goal. The 5 research themes are on-orbit assembly and construction technologies in space, robotics and autonomous system technology, new energy and propulsion technology, environmental control and life support system technology, and new generic technology for spacecraft. The technical terminology can make things a little murky, so let's break down what each of these means. Even just the first of these areas of research is awe-inspiringly ambitious. By on-orbit construction technologies in space, we're talking about developing all the technology necessary to build large space facilities or even spacecraft. In a paper released in 2023, Chinese scientists laid out their goal to develop 3D printing capabilities and other manufacturing tools in orbit. They're already some of the way there. In 2018, they pioneered the first technology to 3D print ceramics under microgravity, which is appropriate for the nation that was one of the first to work with that material 10,000 years ago. Their desire to pursue this goal makes a lot of sense. Getting parts into orbit is a tricky proposition. The Tiangong space station itself had to be built over the course of several launches, with great costs involved, and with risk to delicate systems every time a module was launched. Imagine how much easier it would be if you could simply send raw material up and have it processed and manufactured into usable parts in space. Or even better, to use extraterrestrial materials already up there. The idea is certainly logical, but from the Tiangong's mission goals, it's clear that this has gone beyond the idea stage in China. They are looking for ways to implement it. The paper also describes inflatable scalable structures in space that could then be used as a habitat on neighboring bodies. These lightweight habitats, effectively tents on the moon, would be easy to transport, but aren't limited to the moon. More on that later. Robotic systems would go hand in hand with this. The manufacturing industry back home on Earth greatly benefits from robotic assembly lines. Chinese scientists and engineers are looking at ways robots can perform tasks in space, such as repair work, construction, cargo transfer, and more. Taikonauts are already laying the groundwork by testing robots and their ability to perform in microgravity, such as this test here, where a robot was run through this pipe. But it goes further than just plans for Earth orbit or even the moon. The next research area looks towards developing new forms of energy and propulsion systems. Solar panels are a great way to get electricity in space. However, China is looking into other options, likely because once you get out to the ranges of planets like Jupiter, sunlight is no longer strong enough. NASA's Juno mission is the furthest spacecraft to use solar panels to date, as I talk about in another of my videos here. But by that distance from the sun, light levels drop to just 3% of what we get here on Earth. Hardly enough to support large projects out at that distance. And what this implies is that China is considering large projects at that distance, especially when combined with their aim to create efficient propulsion systems with a long operating life. Any rocket fuel propulsion system can get heavy on long trips, as you have to carry all the fuel you use, unless you can develop it in situ. Due to these increasing logistical costs, outposts that are self-sufficient are incredibly valuable, which is why taikonauts are also actively exploring ways to recycle oxygen, water, grow food, prevent microbial problems, and harmless degradation of waste. This is one of the reasons taikonauts are experimenting growing rice in space. They're also performing studies on the effects of microgravity on living organisms, such as fruit flies, to see how the conditions of space affect life. And just at the start of the year, taikonauts successfully tested a technology that brings oxygen recycling and the need for in situ rocket fuel together. In the first experiment of its kind, using a semiconductor catalyst, taikonauts on Tiangong produce oxygen and hydrocarbon ethylene out of carbon dioxide in an instance of artificial photosynthesis. Hydrocarbon ethylene can be used to make rocket fuel, but researchers also believe they could use the same process to make methane, formic acid, or even sugars, mimicking what plants do on Earth. This discovery is groundbreaking. On the ISS, the electricity required to recycle oxygen using electrolysis techniques is thought to take up a third of the ISS's energy usage. This new process is more efficient, gets rid of the CO2 being breathed, and can be done at room temperature. That's an incredibly useful technology to have on any long-distance space mission. Finally, taikonauts are testing their gear to make sure it works in space. This is the last of the 5 research themes, and while not as flashy as the others, it's a vital step in the process, and one that's difficult to replicate on Earth. The unique conditions of microgravity can put a lot of different strains on machinery. For one example, fluid dynamics are much harder to currently model, for another. And if you want to solve these things, it's practically impossible to replicate microgravity if you're deep within our gravity well. Putting it all together, it becomes clear that China is already thinking very carefully about not just a lunar base, but a vast network of habitats across the solar system, self-sufficient, able to mine resources wherever they are, and with the manufacturing capabilities to construct parts or whole new spacecraft out of it. With this infrastructure and technology in place, China will be able to mine resources from asteroids across the solar system and set up human presences on countless moons or planets. Yes, it's still early days, and it's not like China is alone in this, but it's a sign of how far things have progressed. If China is testing out the technology to build manufacturing bases in space, the platforms themselves can't be that far behind. To be clear, China isn't trying to be secretive about any of this. In fact, the Chinese are very in favor of collaboration. However, under American law, American astronauts are not allowed on board Tiangong without express permission from Congress, something not likely to be given. And although Europe initially planned to collaborate with China, they pulled out in 2023, citing insufficient budget and no political green light. Although European and American nations are wary of it, China has invited scientists across the world to perform joint experiments on the Tiangong station in a spirit of international collaboration and mutual benefit. It remains to be seen whether other nations will join China in these experiments, or whether taikonauts will be doing these thousands of experiments on Tiangong alone. Artificial photosynthesis. Orbital construction facilities capable of building a space rocket. Robotics. In situ rapid growth of food. New power sources. New propulsion. All in all, we are entering into a new stage of space exploration. To date, the furthest a human has ever traveled from our home planet is our moon. We've set foot there, looked around, but soon came home again. China's experiments on Tiangong are signs that a new approach to space is fast arriving, one where humanity does not simply go to space to come back again. We as a species are well on the way to leaving the nest of our Mother Earth and spreading our wings to fly out and discover new territories, further and further onwards from there. I hope we are ready for all that entails.